Welcome to the project demonstration of wireless electrical vehicle charging system using hybrid power. So here for hybrid power generation we are making use of solar panel as well as wind and next grid power connection. So from these three sources we are going to charge a battery, and after the battery getting charged, whenever you want to charge a electrical vehicle through wireless technology, yes, we need to on the power supply to that. So in this version we are implementing with advanced version of full bridge inverting circuit. As we know that when you want to transfer the power through wireless technology, then we need to provide the high frequency based AC signal to the transmitting coil. There's a copper coil. So when we provide the high frequency based AC signal to this copper coil, it will generate the EMF, and whenever we place the external secondary coil of same copper with a less or more number of turns, then when we place that in this region of this copper coil, then this will get induced and it will provide us the induced EMF signal, and that will be converted into the voltage, and that AC signal will be converted into DC with the help of this charging circuit, and that will be the input to this 12 volt 1 amp battery for recharging purpose. So here the transmitting section we are using 12 volt 20 watts DC generator, 12 volt 5 watt solar panel, and 12 volt 20 watts transformer. So these three sources are providing power supply to this battery for charging purpose through the independent charging circuits. Each charging circuit is common and means a common circuit diagram which consists of 4 diodes which will act as a rectifier to convert the AC to DC when we are providing the transformer AC voltage to this one. It will take 230 volts AC input and provide us a 12 volts AC output, and that will be converted into the 12 volts pulsating DC, and the capacitor will get the pure DC of 12 volts, and that is input to the charging voltage of our battery. And the next, coming to the wind. So whenever the wind direction changes, then the direction of the turbine also will be changes, so the polarity also changes. That will be rectified with the help of this bridge rectifier. So either it is a clockwise rotation or counterclockwise rotation, we are getting the same voltage as we are using the bridge rectifier here, which will convert the polarity correction here. Same for the solar panel also, but there won't be any change of polarity. But if any accidentally the person who placed this connector and this slot, if it's connected in reverse direction, then there may be a chance of battery get damaged. In order to protect that, we place these 4 diodes which will act as a rectifier to protect the battery only. Though we are protecting the DC, but these diodes will act as a polarity correctors, not the AC to DC converters in our project. Okay, this is about the chargings from the sources. And the next, once the battery charged, we are providing the same 12 volts DC input to this full bridge circuit, and the full bridge circuit will get the around 150 kilohertz of frequency signals from this PIC16F72 microcontroller, and means it will convert the 12 volts DC to 12 volts AC of 150 kilohertz of frequency. So that is the input to this coil through these capacitors. The capacitor purpose is, as we are using the copper coil, which is resistance of this copper coil is nearby 0. So when we are switching a frequency to this 0 coils, 0 resistance, then the current is more. So then the MOSFETs may get damaged. In order to protect that, we place the capacitors parallelly to the copper coil. So we can just provide the resonance, and from there we can protect the MOSFETs from overheating. And the next, same, this receiving coil receive the signal same frequency, and that will be converted into the DC here, as we have the same 4 rectifiers, and that means 4 diodes, and converting AC to DC, and to the capacitor we will charge a battery here, right? So when you want to charge a battery, solar, like just place this under the sunlight, you get the low voltage here due to this low lighting, and the wind comes, you can see it getting the voltage any direction. And the same for the transformer also. So either from the transformer or a solar or a wind, so continuously power is available, then automatically the battery will get fully charged in duration of 6 to 8 hours. So once the battery is fully charged, right, in a duration of 6 hours minimum, 8 hours maximum. So after that, automatically the respective charging circuits will block the current flow from the source to the battery. Either transformer or a wind or a solar, when you are providing the continuous power. So if you want to charge a battery of vehicle section, just for demonstration purpose, just here we need to disconnect this coil Okay, right. Okay, now connect that transformer at this slot. Right. So here also same 6 hours minimum, 8 hours maximum. So this is for only secondary source of charging for this battery. Before demonstration, keep the both batteries under full charge. That's very important. And after that, let us see the final demonstration of our project. Okay. Right. Now this is the direction controlling for the robot movement. So this is going to be the forward, backward, left side and right side direction. So alternating buttons for this one. Now so on the switch, then you can see the light indication on this one. After the light on off 2 times, now it is transmitting the power. So when the vehicle is coming into the region, sorry, we need to connect this one. We need to connect this over here. Right, you can see that now the vehicle is charging through wireless power transmission. Right, okay. Right, okay. So as a vehicle is charging with the help of the wireless technology without any contact based one.